Okay, question 17. Which one of the following is the correct orbital diagram for nitrogen? So first of all, we'll look at nitrogen on the periodic table. Um, Nitrogen is element number 7, which means it's got 7 protons and 7 electrons. So if we go back and look at the exam, 1, 2, 3, 4, 5, 3, 4, 5, 6, 7. I think all the choices have 7 electrons. This is the correct, they all have the correct number of electrons. So what we have to look at here is the arrangement. Within an orbital, according to the Pauli exclusion principle, electrons have to have opposite spins. And if we look at choice 2, these 2 electrons have the same spin, so that's not correct, and so do these. So that leaves like 1 and 3. And then, so these have electrons with the opposite spin in the same orbital. But then we also have Hund's rule that if electrons are in different orbitals within a subshell, they're going to have the same spin. They're going to be in separate orbitals, but have the same spin. So it would be the third answer here. These have opposite spins, so it would not be choice number 1. What element has at least 1 electron in the d orbital? So for this, again, we need to look at the periodic table. And I'm going to move this over so we can hopefully see our answer choices while we're looking at it. All right, so we have the d orbital is the orbital of transition elements. So scandium is in the is in a transition element, and this is the d block where the d shell is filling. So scandium, in fact, is the first element to have an electron in the d orbital. But let's just look at the other choices. So calcium and potassium and calcium are both right before scandium. So they have the S subshell filling, but they do not yet have they don't have any d electrons because that shell isn't filling until we get to the d block. So it would not be either of those. And then argon over here, that's in period 3. So remember, we have the S subshell. So basically the D shell subshell does not fill until we get to group 4. So basically a scandium is the choice there. Which of the following statements are true about D block elements? D block elements are all transition metals. That's true. So basically, D block is this lower down here. These are all the transition metals by definition. The D subshell is filling. That's also true. That's why we call it the D block. Some D block elements can form more than one type of ion. So basically, if we look here, chromium and manganese, for example, and iron and cobalt, all of these can form more than one type of ion. So this is true as well. So all of the statements are true. Then question 20, match each element with the group to which it belongs. So again, this is something that you can look up on the periodic table. So transition metals. Let's look at the answer choices here. So argon, first of all, if we look at argon, it's on the very far right group. So you should know that this is the noble gases. So that would be a noble gas here. Now we look at iron. Iron is right in here. This is the transition metals, this lower down part of the table. So that would be a transition metal up here. Now sodium, if we look at sodium, it's in group 1, and that's the alkali metals. And then fluorine is in group 7, and that's the halogens. Next, chlorine and bromine have very similar chemical properties. This is best explained by the fact that both elements, so let's look at the answer choices here, are in period 3. And first of all, let's look at chlorine and bromine. So they are not in the same period. Chlorine's in period 3, but bromine's in period 4. Have an equal number of protons and electrons, and that would not be true for any 2 elements, because by definition, each element has a different number of protons, so that could not be the answer. Have the same number of valence electrons. All right, so chlorine and bromine are both in group 7, which means they have 7 valence electrons. So that looks like the correct choice. And then our gases, bromine is actually liquid at room temperature, so they're not both gases. So it would be, they have the same number of valence electrons. So question 22, the size of an atom generally increases up a group and from left to right across the periodic table. So basically, if we remember the periodic trends, size increases down a table because we have more electron shells fill it, and each shell is larger than the last. So it's not going to increase up a group, so it's not that. Okay, it does increase down a group. And then decreases from left to right. So let's read that. So it does increase down and decreases from left to right. So that is true because basically as we go across the table, the nucleus gets more positively charged and makes the shell essentially smaller. So that is true. Let's just look at the other choices though. Increases diagonally from bottom left to top right. So that is not true because it basically increases going down the table and decreases across. Increases up a group, and again, that's not going to be correct because we know that it increases down a group. Decreases down a group, and that's also that's essentially same as increases up a group. So it's the second choice here. What is ionization energy? And it says none of the above, but it's actually none of the below would be the choice. But let's look at the choices and see which one is actually correct. It's the energy required to add an electron to an atom in a gaseous state. That is not true because that is what electronegativity is. The energy required to remove the loosest electron from an atom in gaseous state. So that is correct because that is what ionization energy is by definition, but let's just look at the other two choices. The energy required to remove all of the electrons, so it's not all the electrons, it's just one loose electron, and then the energy to remove the tightest electron, and that's not the choice either. So the loosest electron is the one that's going to be lost first, and that's what ionization energy measures. And then the question 24, which metal atom below has only one oxidation state? In other words, can only form one charge. So let's look again, we can look at the periodic table and see. So iron, if we look at the oxidation state, that's number in the upper right-hand corner, iron can form two different ions. So it's got two, that's what it means. Oxidation state is positive of the charged ions that it can form. Iron can form 2, chromium can form 3, manganese can form 4, so it is none of those. And if we look at barium here, it has only one oxidation state, +2, and this is true of all group 2 metals that can only form a +2. So it would be barium.